All right, law of sines. Finally, getting the video for law of sines. I'm sorry if you were absent that day. Okay, so before we talk about the law of sines, we need to talk about a couple of things. First, conventions. Conventions just mean that if there's a way that things are usually done, it's called a convention. In math, we have some conventions with triangles. The first convention is typically we label our angles with capital letters. If it's a right triangle, in fact, we usually reserve the right angle to be letter C. And again, this is just a convention. It's the way things are usually done. Not always, but usually. If those angles are labeled with capital letters, we use the lowercase of the same letter for the side across from it. So if this is angle B here, the one across from it is side B. If this is angle A here, the one across from it is side A. So we'll be using those triangle conventions throughout the unit. We talked next in class about finding the area of a triangle, and we talked about a proof of that. I'm going to skip that for the video. The formula for the area of a triangle that you are used to using is 1/2 the base times the height. I labeled it. And what we want to find is a formula that we can use that doesn't include height, that's only dependent on the sides and the angles of the triangle. So here are our formulas. Area is 1/2 BC sine A. Now there's two other versions of that. It just depends on which angle is involved. And those versions just go with each of the angles in the triangle. You can try to memorize letters if you want, but I just always try to think of it logically. The formulas are always going to be half. That's from the fact that they're triangles. If we have angle A, the two sides that you use are going to be the two sides that are adjacent to angle A, the two sides that are forming angle A. If you have angle B, the two sides that you're going to use in the formula are the two sides that surround angle B. If you have angle C, the sides that you're going to use in the formula are the two sides surrounding angle C, so side A and side B. So let's see how we can do this in a problem. So if we have side A, that's 11. Side B, that's 5. And side C, that's 6.5. And we know angle C is 20 degrees. Well, if we want to do the area of this triangle, or find the area of this triangle, we're going to use angle C. That's the only one we know. And we're going to use the two sides that form angle C. So our formula is going to be, if we want a formula, 1/2 AB sine C. But again, I think just remember you're using the two sides that surround the angle. 11, 1/2 of 11 times 5 times the sine of 20 degrees. And we can have our calculator calculate that for us. Make sure your calculator is in degree mode. And it's always going to be a sine when you're calculating the area. So the area is 9.4. I am going to skip the second example for time and go into the law of sines. I'm not going to do a proof of the law of sines today. Law of sines is as shown on the screen. Typically it's written this way: sine A over A equals sine B over B equals sine C over C. The angles and sides in a triangle form these proportions. You can also write it the reciprocal of that, which is to put the sides on the top. Side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. Those are the two ways you could write the law of sines. Now, this equation that's written here, this law of sines, has three parts. Now, having just those three parts is shorthand. You never use all three parts at the same time. It's just sort of condensed into this three-part equation, but when you're actually using the law of sines, you only use two parts at a time. You pick the two parts that you need to use to help you solve your problem. So for example, if you know angle C and side C and side B, you might set up your equation like this, and that's going to help you find angle B. And you'll get used to setting up your equations after you've practiced a few times, but you're never going to use all three parts at the same time. Okay, for this triangle, here's how we're going to start. For this triangle, we need to find the lengths of side A and side C. Well, for this triangle, you might notice that we know angle C and we know angle A. Well, if we know angle C and angle A, we can quickly and easily find angle B. The angles in a triangle add to 180. So if we find angle B, and by just subtracting those other two angles, 180 minus 118 minus 22, we find that angle B is 40 degrees. I'm going to add that to my drawing. Okay, so now we can find side A. Now when you're using the law of sines, you always want to look for a pair of A's, a pair of B's, a pair of C's. In this case, we do have a pair of B's. We have angle B 40 degrees, we just calculated that, and we have side B. Well, we're going to use the fact that we know both of these B values in order to find that A value. We're going to solve for side A first. If I'm finding side A, I like to put that in the numerator. So I'm using the version of the law of sines that puts the sides in the numerator and the angles in the denominator. So I have A over sine A equals, and I'm going to use the B's, B over sine B. So this is the version of the law of sines that I'm going to use for this problem. Well, if I fill in the information that I know that sine A is 118 degrees. I know that side B is 24. And I know that angle B is 40. Well, at this point, I have an equation that just has that one variable A. I'm going to try to solve this equation for A. Well, the way I'm going to do that, since A right now is being divided by the sine of 118, I'm going to multiply both sides by the sine of 118. And on the left side, those signs reduce. So I have A is equal to 24 times the sine of 118 degrees over the sine of 40 degrees. It's probably not necessary for you to rewrite that. So if we calculate that in our calculator, we can 24 times the sine of 118 and divide that by the sine of 40. The only thing you need to be a little careful of is make sure you end your sign with parentheses there in your calculator. And this tells us that side A is equal to 32.97. So I'm going to add that onto my diagram. Finally, we're going to find side C. So if we set up the law of sines equation to help us, we're looking for side C. So I'm going to put that in the numerator. And again, I have both of those B values, so I'm going to use those B values to help me find this length of side C. So if I fill in the information that I know, C over the sine of 22 degrees is angle C. Side B is 24, and the angle B is 40 degrees. So here's my equation. And like last time, I want to get this length of C all by itself or solve for that one. So I'm going to multiply by sine 22. Those ones reduce. And if we calculate this value in our calculator, we get 13.99 is the length of side C. And now we're finished. We found the two sides we were looking for. It can be a little more challenging to find an angle. In this example, I am going to find angle B. So if I want to find angle B, the version of the law of sines I'm going to use, well, I'm looking for angle B, so I'm going to do B over the sine of B. And as I look at my diagram, I've got to decide, it looks like we have angle A, and this is side A. So we can use the A's to help us. So we have B, oh, sorry. I set that up. I'm sorry, I'm trying to go really fast. We're actually looking for angle B. So I'm actually going to rewrite this as our other version with the angles on top. Same letters, just because this is what we were looking for, I'm going to do the reciprocals there. And it's fine. You can do, as long as you're consistent, it doesn't matter which one you're putting in the numerator. If you want to put the angles in the numerator, that's great. If you want to put the side lengths in the numerator, you can. I would use this version because I'm looking for angle B. So let's put our information in. The sine of B, that's what I don't know, over 2 is equal to the sine of 40 degrees over 3. So this time to solve for B, again right now it's the sine of B divided by 2, so I'm going to multiply both sides of my equation by 2. And so I have the sine of B is equal to, and if I calculate this, 2 times the sine of angle 40 divided by 3, my calculator tells me that that's 0.4285. Now that's the sine of B. So if I have the sine of angle B and I want to know what the angle is, I have to do the inverse. And so if I do the inverse in my calculator, I find that angle B is equal to 25.4 degrees. So that's how to use the law of sines to find an angle. That's all I'm going to include in the video, how to use it to find a side, how to use it to find an angle. If you are doing a problem and it asks you to solve the triangle, it is asking you to find all the missing sides and angles, so you will have to go through and perhaps use the law of sines twice, or sometimes you also need to use the fact that the angles add up to 180 degrees. But I have at least shown you how to find a side and how to find an angle using the law of sines. If you need help or want some help to work through some of the problems, particularly the more challenging ones, please come in and talk to me. I'm around almost all the time, just not Thursdays after school. So please come in and I'll help you if you are absent and need some additional help with this concept. Thank you.